All right, so to review what we talked about yesterday with angles and polygons, first we defined what a polygon is, a two-dimensional figure formed by three or more straight lines called sides. Then I had you fill out this chart with a triangle being the smallest polygon possible. We know that a triangle, we'd already discussed that the angles of a triangle add up to 180 degrees. So I had you fill out this chart about the number of sides in the polygon versus the number of triangles in the polygon to find the sum, because we know that if each triangle is 180, we can multiply that by the number of triangles to find the sum. And we saw that the number of triangles was 2 less than the number of sides, which led us to this formula for the sum of the interior angle measures. S equals the quantity n minus 2 times 180. And you applied that to these 4 problems, and we have a 15 gon, a 21 gon, a 48 gon, and a 36 gon. And we said really when it gets above 12 sides, we stop using names. 12 would be a dodecagon, do for 2, decagon 10, 2 and 10 is 12. Once it gets above 12, we usually just go to numbers. And if we break down the word polygon, poly means many, gon is side, so it's a many-sided figure. So when they do a 15 gon, they are talking about a 15-sided figure. All right, so we applied that sum formula to these different sided figures. And then we talked about the idea of a regular polygon. A regular polygon, it means that all the sides and all the angles are congruent. So that if we know that it's regular, then we can find each. And each would be taking the sum formula and dividing it by the number of sides to find out what each angle would measure. And we applied that to a regular pentagon, which would have 5 sides, and a regular 18 gon, which would have 18 sides. Then we were moving into the exterior side, and we said exterior angles are supplementary, which means they add up to 180. And the reason that they are supplementary, when we look down at the triangle there, we notice that they're all linear pairs. So if we know the inside angle, we could subtract that from 180 to find the outside angle. And then they asked us to add all of those up and see what our sum is. So we finished the triangle yesterday. When we left, you were working on the quadrilateral, the pentagon, and the hexagon. So I'm going to pause for a moment and come around and see where we are on those 3 before we go over them. All right, so let's look at what would be these exterior angles. I'm going to start here on the quadrilateral. I'm going to start with that interior angle that is 71 degrees. And I'm going to ask, when I ask these questions, I'm going to say, what is the supplement? To be the supplement, it's what number would add up to 180 with the 71. So what would be the supplement to 71 degrees? 109. So this exterior angle here would have to be 109 for them to form that linear pair. What would be the supplement to 124 degrees? 56 degrees. The supplement to 76? 104 degrees. And the supplement to 89? 91 degrees. So that was the first part. It says find the measure of each exterior angle. Then they wanted us to find the sum, so we have to take that 109 plus 56 plus 104 plus 91, and what do we get? 360. So we got 360 degrees again. Now the pentagon, I'm going to start at the 104. What would be the supplement to 104 degrees? 76 degrees. The supplement to 98? 82 degrees. The supplement to 121 degrees? The supplement to 87 degrees? And the supplement to 130? 50. And then again, if I take that 76 plus 82 plus 59 plus 93 plus 50, what do I get? 360. And then the hexagon, I'm going to start at the 117. So what would be the supplement to 117? 63. So 115 would be 65 degrees, 129. 51 degrees, 124. 56 degrees, 112. 123. 57. So those would be the exterior, again, based on that idea of a linear pair, that of an interior and exterior angle that are next to each other would have to add up to 180. And then if I take 63 plus 65 plus 51 plus 56 plus 68 plus 57, what did I get? 360. So what did I get the sum for each problem? So what can we conclude about the sum of the exterior angle measures of a polygon? They're going to equal 360. The sum of the exterior angle measures of a polygon is 360 degrees. Now that's any polygon. You notice the polygons we had above were not regular. We had different angle measures at each vertex, so they were not regular. To apply this to a regular polygon, if we know that the sum is 360, then we could find each by dividing that 360 by the number of sides. So for a regular polygon, bless you, each exterior would be 360 divided by n, where n is the number of sides. But again, that part only applies if it is a regular polygon, because we know if it's a regular polygon, that all angles and all sides would have to be the same. And if each interior angle is the same, that means its linear pair on the outside would have to be the same all the way around, and it should still add up to 360. So now when we look at problem number 7 here, it says, what is the measure of each exterior angle of a regular hexagon? So key part there, they are saying regular. So we do know that it is equilateral and equiangular. How many sides does a hexagon have? 6. So we know that n equals 6 in this case. So each exterior is going to be 360 divided by 6. So what is going to be the measure of each exterior angle? What is 360 divided by 6? 60 degrees. So each exterior angle of a regular hexagon has to measure 60 degrees. Number 8, what is the measure of each exterior angle of a regular 24gon? Again, we're seeing regular, so we know that each is equal. 24gon is telling me that my n value here is going to be 24. There are 24 sides. So here, each exterior is going to be 360 divided by 24. So what is the value of each exterior if we take 360 and divide by 24? 15 degrees. And that makes sense because as the figure gets bigger, the angle insides are going to have to get bigger, which means the angles outside are going to have to be smaller to accommodate that bigger angle inside. So it makes sense at 6 sides we had 60 degrees outside. At 24 sides we have 15 degrees outside. Now 9 and 10 are going to kind of work backward from that. They're going to tell us, hey, I'll tell you what the exterior angle measures. You tell me how many sides it has. So if the exterior angle of a regular polygon measures 12 degrees, how many sides does the polygon have? So here's our each exterior. We know each exterior is 12. So when we go to set it up, now we have 12 equals 360 divided by n. We had to divide 360 by some number of sides to end up with 12 degrees. So now we have to remember how to solve when the variable's in the denominator, which means we have to multiply it out. We need to get it out of that denominator in order to be able to solve. So I multiply both sides by n to clear it out of there. So now I have 12n equals 360. I'm going to divide by 12. And that's going to tell me how many sides. So what is 360 divided by 12? 30. So this means it has 30 sides. And that makes sense. In question number 8, we had 24 sides and our exterior angle was 15. In question 9, our exterior angle was even smaller, which means we had to have more than 24 sides. And 30 is more than 24. So that makes sense for the value that we got. Number 10, if the exterior angle of a regular polygon measures 40 degrees, how many sides does the polygon have? Again, I know each exterior right there is 40 degrees. So I'm going to have 40 equals 360 divided by n. Again, I have to clear that denominator. So I'm going to multiply both sides by n to clear it so that I have 40n equals 360. And if I divide both sides by 40, what does n equal? 9. So to have 40 degrees outside, we must have a nonagon. We must have a 9-sided figure to make that happen. Now, in just a minute, I'm going to pass out the practice for this assignment. I will tell you the practice you might have is more on application. It's not just repeating what we did in the notes. There are going to be a few different problems where you're applying everything we've learned in the notes. The very first part of the assignment, though, has you writing down all the formulas. So I want to make sure we get all those written down correctly so that we're using them correctly. So I'm going to pause here, hand out the assignment, and then I'm going to make sure we write down those formulas correctly. All right, so let's talk about the formulas that you filled in here. So let's talk about for any polygon, that top line. What am I putting in for the sum of the interior angle measures for any polygon? S equals parentheses n minus 2 times 180. The number of sides minus 2, which will tell us how many triangles is inside the polygon, and multiplying that times 180, which is the number of degrees in a triangle, will tell us the sum. What about the sum of the exterior angles? What did we say was the sum of the exterior angles of any polygon? 360. This is just S equals 360 degrees. Again, that's for any polygon. That's where we took the interior angle subtracted by 180 and got the exterior angle. Now the next line is specifically referencing regular polygons. We can see it right here. Now we're talking about regular polygons. So how do I find each interior angle of a regular polygon? Each equals it's that sum formula, and then we have to come back and divide by the number of sides. So we're taking that generic sum formula, n minus 2, the quantity n minus 2 times 180, and we're dividing by n. What about each exterior? Each equals 360 divided by n. And it says for the next one, the number of sides of a regular polygon. Again, each exterior equals 360 divided by n. So we can use that same idea to work backwards to find the number of sides. So I wanted to make sure that you have the correct formulas there so that as you're working through the assignment, you're pulling from the correct information. So I'm going to go ahead and stop now so that you can continue working on this assignment.